This is the ROS Developers Podcast, episode 106.
Podcast the ROS Developers. The ROS Developers. Podcast the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that give you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct. You can see here, around there, yeah. And today, I would like to dedicate this episode to all those people that are doing some research in order to make their robots more easy to communicate, so that we can, in some sense, provide what we want them to do in an easier way, so that we can understand their feedback, so we can happily live together and help each other and have a better robotics life together. Whatever. Okay. And today we are going to talk about a subject which is called human-robot interaction, which is related to this. And but before going into that, I would like to mention to you about our online academy that we have, The Construct. You know that we have an online academy where we are doing we are providing ROS courses, especially now we are pushing a lot into the ROS 2 courses that we have, especially teaching about ROS 2 basics, ROS 2 navigation, manipulation. You can learn about how to make the TF properly work, how to spawn URDF models in ROS 2, and how to transition from ROS 1 into ROS 2. So in case that you are interested to get into ROS 2, because now is the moment to do it, then you can check our online academy at www.theconstructsim.com. I'll put a link into the show notes, okay? And that's now for... So we have to go now into the our speaker of today. For today, let me introduce you Séverin Lemaignan. Severin is a senior scientist in social robotics at Pal Robotics. And there he works to develop ways to make communication between humans and robots in an easier way. And today he is going to explain us everything about HRI and his project about how to get a general framework of HRI into ROS. Welcome to the podcast, Severin.
Hello, welcome. Thank you for having me.
My pleasure. I can see some of your colleagues there that are watching the interview.
Yes.
Which one is that one?
I invited Ari, our robot Ari, with us today. It's our more social robot, and that's the main platform that I'm using to develop all these human-robot interaction projects.
Okay, great. Then, you are mentioning already HRI, and maybe some people of the audience doesn't know what it's about. What can you tell? When you talk about HRI, what do you actually mean?
Yes, so HRI, human-robot interaction. That's one of the kind of active, pretty hot topic right now in robotics, and it's all about how we get robots to do things with humans in a better way. And it's really about both like understanding what the humans want, what they're doing, what they intend to do. So there's a lot of like predicting their behaviors. And then it's of course as well deciding what the robot should do next to help the human. So it's really looking into how we can get humans and robots to do things together.
And does that include how the robot expresses to the human, so the human can also understand what the robot is going to do, or he needs something? Yeah.
Absolutely.
Okay.
And it's a pretty tricky topic, to be honest with you, because humans are we humans are very messy. are very complex, are unpredictable. We keep on changing our mind. And, when a robot is interacting in a typical environment, I don't know, like a warehouse robot, the robot is manipulating boxes. It expects the boxes to be at a given place, and the boxes are not suddenly going to disappear or move or change their mind. No, they are just there.
Yeah.
When you're in human-robot interaction, you have to deal with the fact that you can never really rely on the human to do what you think it should do or where you think it should be. It's very dynamic, very, very. You need to accept the fact that you will never have a well understood, well static environment. And I guess our job in the human-robot interaction community is to try to, crack that nut of how we can model the humans, how we can do things with them, and accept the fact that humans might change their mind, and it's not a bug on the human side. That's what humans are about.
Yeah. Exactly. Okay. And then, so why do you think that this is so important that we incorporate human-robot interaction into robots? Because I don't know. So far, right now, if I have the Roomba, so I push the button and then it starts cleaning. So what is the point of adding human-robot interaction into robots?
Well, that's a really good question. Yes, you're right. I mean, we already have robots in our homes. Roomba is a good example. You have a couple of other examples, like your lawn mower or things like that. But then that's about it. Because actually, as soon as you want a robot to do something useful for you in your home, well, very quickly the robot will have to ask you what you want, or to adjust to the fact that maybe it did not, or the human did not quite understood what had to be done, or maybe the robot did not understand that. If I don't know, I mean, everybody is dreaming of a robot to do the laundry, or to to wash the dishes, or exactly. Or maybe, I don't know, to do some babysitting while you're going out to the movies, or I don't know, or just be around with your granddad or grandmother that can stay at home a bit longer because the robot is there to help them to, I don't know, like pick up things that fall on the floor, or ring an alarm if something goes wrong, or remind them about their medication. To do all that, you need a robot able to interact with the humans. And it's not just, it's a bit more complicated than just an app that would ring to remind you to take the medication. You need to know where the person is, to track her, to place yourself at the right position, to be acceptable. We have all those social norms that get into the picture so that the robot is behaving as it should in a social environment. So all that are examples of why it's both difficult and important to work on enabling smoother human-robot interactions.
Yeah, actually, now that you mention, maybe it's not even going to be possible to make robots do some things without human-robot interaction, because it will be like a nightmare to provide to them all the details and all the things that the robot has to take into account in order to accomplish the tasks. So all those things that we express and that we don't have to indicate in a list of things that you have to do. Maybe with human-robot interaction, the robot can infer all this information.
It's a really good point, actually, because what you're also referring to, I guess, is machine learning. Machine learning is such an important part of human-robot interaction. We cannot tell in advance everything the robot has to do because we don't know, and things will change and will evolve. So we need systems able to adapt to unexpected conditions, but also systems able to learn. And that's a really important trend right now in human-robot interaction, to see to what extent we can use machine learning to learn from the humans and learn to adapt to the humans. So yes.
Okay, so machine learning is one of the main tools that you use in human-robot interaction.
I don't know if I would say it's the main tool. I think it's
one of them.
Yeah, exactly. It's really about combining what we call like model-based approaches. We have like for instance, a 3D model of the human, so we can infer the position of the I don't know, like the arms, the head, the gaze. The gaze is such an important cue when you're interacting with humans. where the human is focusing his attention is so important to interact with them. So we use a lot of model-based approaches, and actually we're going to talk about that in a minute, because a lot of the work in ROS for HRI, the framework I've been developing, is about defining models that people can share and can use. But the real question is, how can we combine those models with machine learning at some point? It's not completely clear. I think it's a very active research topic. Back in the days during my PhD, I was using a lot of symbolic reasoning, like logic reasoning.
Yeah.
And it took us quite a long way down the road. We were able to achieve a lot of really interesting interactions with humans with that. But we also touched with our fingers all the limitations of that, and the fact that the robot was not able to deal with things that were outside of the domain of knowledge he already had. So yes, I think HRI is really an interesting topic, an interesting domain at the crossroads of so many different techniques.
Other techniques, yeah.
Reasoning, machine learning, you get it all really.
Okay. And then, so what is about this Open ROS standard for HRI? So what does it try to achieve? So
for all the people listening to us today, they probably already know that ROS is it's the standard. I don't know, 90%, 99% of the people developing robots are using ROS. And one of the reasons why ROS was so successful is that it did provide, from the beginning, very mature pipelines to do things that were considered as difficult before. And the best example of it is navigation. Now, no one think about navigation because you use the ROS navigation stack, of course, and you get the mapping, you get SLAM, you get localization, you get planning, global planning, local planning, all that is there, of course, yeah. No, it doesn't mean that there is no open research question about SLAM, and you still see new SLAM algorithms, but navigation as a complex thing,
yes,
is solved because we exactly know, oh yes, we need those 5 components, there is default ones, basic ones, and we can replace them with better ones if we want to. Now, there is nothing like that for HRI. And one of the reasons is, I think we already hinted to it in our discussion so far, like, it's just complicated. We don't have any good model of how to do that. And I'm pretty sure that when the Willow Garage and all those people who started ROS, when they were looking at navigation, for them at that point, they were in the same position, like, oh wow, that's a complicated problem. There is so many different ways of doing it. Some people have tried that and that and that, but there is not a single standard way of doing things. And that's exactly what we are trying to achieve for HRI with this ROS for HRI framework. It's about setting the frame for how to deal with HRI. We are not forcing any algorithms, even though we are trying to provide a reference pipeline that works for basic cases, but it will be completely open for people to test their own algorithms, exactly as people can use their own SLAM in navigation. People will be able to use their own, I don't know, like body detectors or expression or emotion recognizer as they want, but at least we offer a structure for that to make it easy for people to share their code, to test their code, and also for people who don't want to research that topic, to have something that works out of the box.
Yeah, okay. Then, well, but when you mention about working out of the box, that means that you are going to provide also some algorithms that are already working. So not only the structure, if I have correctly understood, okay, so your framework of HRI for ROS consists of a set of specifications about how to do things in HRI for ROS, as well as defining, for example, the type of messages that you are going to use. I'm going deep into the ROS stuff, right? So then you specify the ROS message if you want to exchange information between different parts of an HRI system, right? But also you provide algorithms also?
So you're right. The standard itself does not provide any algorithms. It does not specify any algorithms.
Okay.
It's just the standard. However, there's a really interesting aspect of the standardization process in the ROS community, and that aspect is that if you want a standard to be accepted, you need to show that it works.
Yes, exactly. Okay.
Open source way.
Okay.
Actually, that's something we are very not only happy to do, but also glad to do. It's really about contributing back to the community. So yes, alongside the standard, which is a document, a written document, there is a set of tools that are one possible implementation of the standard.
Okay.
And actually, to be more specific, that set of open source code can be really split into two parts. There is what I would call like the foundation, the infrastructure, and like for instance, all the HRI messages. Yes, there is a repository. It's today on GitHub. It's actually you can even it's in ROS, so you can apt install it today if you want. That will install all the HRI messages defined in the spec. There is something like that there is a package called human description that is a URDF model of humans that can be used by everyone, by RVs, by your own code to have the full kinematic model of the humans. So this is already there. It's a basic piece of code. There is a couple of libraries, for instance, to access and make it easy to integrate ROS for HRI in your own code that are also part of this kind of basic set of nodes. And then, next to that, there is a couple of detectors of algorithms that implement part of the pipeline. For instance, to detect a face, to detect a skeleton, to detect, emotions, things like that. So there's a couple of nodes, not too many, and hopefully in the coming months, we will push more on GitHub. But there is already, like, if you go today on the ROS for HRI organization on GitHub, you will see already like quite a few packages that can be used today to do that.
Off the shelf.
ROS for HRI off the shelf, yes.
And do you have any for the gaze, for example, that you mentioned before? Because you mentioned that like something very, very important in human-robot interaction. Yes,
absolutely. So gaze, there is a node called HRI face detect. Well, it's a package that contains one main node that detects a face in an RGB image or optionally in an RGBD image, and will extract the key points on the face, will estimate the position in 3D of the face, and will will provide you with a TF frame that corresponds to the gaze direction, the infrared gaze.
Okay, so we can even visualize this in RBS, right?
Yeah.
It's another frame, yeah.
Actually, that's also something I forgot to mention, but we've also created a couple of plugins for RVs to simplify the display of all those messages and all those new type of information. Like, for instance, to display 3D models of humans and as many as there are humans. So yes, it's fully integrated with RVs. Yeah.
Oh, that's awesome! Sounds super interesting, and I'm eager to test it and to try to make use of that.
This node, HRI face detect, unfortunately is not in Noetic, for instance, is not already packaged because it has complicated dependencies. Well, dependencies to package that are tricky. It relies on Google Media Pipe. I don't know if you've heard about it, but Google has released a set of pre-trained networks for a lot of tasks, object detection, body tracking, that are working really well, that are super fast, run on the CPU, don't need a GPU, really good performances, but they are a nightmare to package. So we haven't been able to put them in the normal distribution because of the dependencies. But the code is there, it's open source, it's actually quite easy to install. It's a Catkin build, whatever.
Yeah, you do the clone and then you just compile and that's it. And when you mention Catkin build, it means it's for ROS 1.
So yes, currently all the development has been done for ROS 1. So actually I should probably subscribe to one of your classes on the ROS 1 to ROS 2 transition. The main reason, and I know you're going to hate me for saying that, but the main reason is that currently, especially as a company, we have basically no demand for ROS 2 support. So all of our customers are using ROS 1. And yes, it's definitely on the roadmap to port all that to ROS 2. Actually, I had a really interesting discussion with the ROS steering committee about that. that's probably the first question they asked me is, do you support ROS2? I said no. And they told me, yeah, that's fine, because actually the standard, the ROS HRI standard would be very easy, would require very little changes to be completely ROS2 compatible. And then the implementation of the nodes, I don't know at what, in the short term, we are not going to do the port to ROS2 because we have no need for that. But then, of course, it's completely up to the community to develop whatever they want. I mean, it's to be fair, like the HRI face detect node, to take that example again, is actually fairly simple. It's essentially wrapping this Google Media Pipe detector. So it would not be a huge effort to port it to ROS2, I don't think so.
Okay. That's a strange what you mentioned about not being requested for ROS2, but I think that's a discussion for another day, maybe with a beer.
We are all very, very well aware that ROS1 end of life is now getting really close. So there will be a massive move to ROS2. I hope so. And on other, like if you take a robot like Harry, the one that is behind me, that robot fully runs on ROS1, but we already have prototypes for all the lower level part of the robot, the navigation, the controllers. All that is already ported to ROS2. So as a company, we are very well aware of that, and so we will, I don't know, within a year or something, move to ROS2.
Okay.
But yeah.
But at present, you don't feel that pressure. That's what you mean.
Yeah, exactly. It's not the highest priority right now.
Priority. I see. I understand. And then, okay, so why would somebody adhere to that set of specifications that you are presenting with human-robot interaction for AI? Because I'm pretty sure that there are a lot of other projects that are trying to do human-robot interaction, maybe not with ROS, maybe with their own frameworks. So what is the advantage to follow your suggestion, your proposal?
Actually, the first time I thought of developing something like ROS HRI was something like 5 years ago. It took us about 5 years to actually come up with something that works. And the reason why I'm saying that is it sounds quite obvious at the surface that, yeah, okay, of course, we need a set of standard conventions for humans. That makes sense. And surely, like a lot of, as you said, like a lot of people have done that before. Well, actually, no. that was the first surprise. A couple of years ago, when I was working at the university, actually in the UK, in Bristol, we're like, okay, so what are the tools we should use to deal with humans? Well, there is none. And actually, when you look into that, it's quite interesting. You go back to the origin of Willow Garage and ROS and PR2, for those of you who know the PR2 robot. Back in those days at San Francisco, Willow Garage did develop, it was Caroline Patton-Farroux who developed that, a first package called ROS Humans.
Okay.
And yeah, no one knows about it because it was really very, very limited, and it was never really doing anything beyond detecting humans based on their legs, essentially, like using the laser scanner. There's a couple of attempts since then, but really like less than 5. You can probably count them on the finger of one hand. Trying to build something like a framework for human-robot interaction, but it never really led to anything, because at the end of the day, most of these attempts were driven by the specific needs of one project, and they never really thought in terms of, what are the right abstractions to make sure that what we're doing will work for everyone. And when I say everyone, ROS HRI, the standard that we're talking about today, can be used as well by people doing, crowd simulation, people doing learning from demonstration, where they are just working with one single human, but they need a very detailed kinematic model of the human. Mm-hmm. It would work with people working only on social aspects, where they want to recognize, emotions, but they don't really care about the 3D model of the human. That can work for people that are only interested in navigation and they don't really need to have any details about the face or anything like that. They just want to have an accurate position of the humans, orientation of the humans to navigate around them. we've tried hard to cover a really broad range of human-robot interaction scenarios. And I guess to answer your question, what is the main advantage of using something like that? Well, it's just that there is nothing else really. I'm not saying that what we've done is perfect. It's actually, and we might come back to that a bit later on. It's still in the draft status. There's this official draft status, so it's open for feedback from the community. But we've really tried hard to design it in such a way that it could be useful for a really broad range of applications. If you allow me, I would like to go one slightly more specific challenge that we've tried to address in this specification. If you've ever tried to do a little bit of, not even human-robot interaction, but just detecting humans to, I don't know, avoid them or things like that, there is one thing that people have to deal with very, very quickly. The fact that, I don't know, like a face detector currently is extremely easy to implement. OpenCV has a face detector, 5 lines of code, and you know the bounding box of the person. Now, what happens if I do something like that with my hand? So I'm hiding my hand. I'm hiding my face with my hand, and then my face reappears. If you ask the OpenCV face detector to do that, very easy. You will get a face and then a new person. Because there is no concept of
continuity
of the person. Now you can have a person like an identification, a face recognition module. Fine, but the same problem occurs all the time. Like if you have like a body detector, as soon as the body is lost, you redetect it, it will be a different person. Yes, you might be able to do a bit of tracking, but it doesn't work really well when the person disappears, reappears. Same thing with voices. If you hear someone, you go, I can hear someone, and then you hear again the voice, how do you know it's the same person without running a set of algorithms? The problem is some people don't care about tracking the people. They just want to see, oh, there is a face, so I'm going to look at that. We are going back to what I was saying before about covering a broad range. So a lot of the work we've put in this ROS for HRI standard was a way to organize or to account for the fact that sometimes we have detections that are very short-lived. We call them transient. And sometimes we have things that last forever. If I've seen you today, Ricardo, if I see you in a month's time, I will still know that percept, your face is still you, Ricardo. And so there is also the concept of permanent things in the ROS for HRI standard, that you might have a person that even if you don't see it anymore, the person still exists. It's just not there right now, but it still exists. And you can reason about it. You can represent it. If you know about the name of that person, the name does not disappear as soon as the person is not seen anymore. Things like that. So this little dance between short-term, short-lived percepts and long-term permanent concepts is one of the really slightly more tricky bit of the
features. Can we say features or functionality that the framework provides to
and we provide all the semantic associated to each of the IDs, like short-term IDs for the faces, long-term IDs for the people, how they are connected. What happens if I see you, so I know you're a person, but I haven't recognized you yet. So I need to see, I see your face, I know that there is a person that exists, but I cannot yet set a name or a permanent ID. All those semantics are actually quite tricky. And so we try to address that in the spec.
Okay, so clear now the benefits. And then let me see here. So you provide ROS for HRI API. So what is that for?
Yes. So when we talk about an API, it's not really an API, but what the ROS for HRI REP, the ROS Enhancement Proposal, which is now this kind of official document, official ROS standard. Okay. What the document sets.
Okay, wait. So let's clarify about this, because Too many acronyms, and then maybe the audience is getting lost. So you are talking now about the REP document, right? That is the one that describes your specification. Can you tell us more about this document? What is this for, and what is the purpose of creating this document?
Yeah. So just a few words about the way the ROS community works in terms of creating new standards. If you have an idea for something, it can be, I don't know, like a new driver, a complex system like ROS for HRI, or a way to name TF frames for such or such application. You can create a document called a ROS Enhancements Proposal, REP. And that document, there is a GitHub repository. You will create a pull request on that repository saying, "Oh, this is my new proposal for a standard. What do you think about it?" And then on that GitHub repository, the discussion that will start, a discussion with the whole ROS community. And if there is enough support for the proposal, that pull request will be merged by the steering committee, the ROS steering committee, and will move to the official REPs, the official reps that you can access on the web. Maybe we can add the link to the list of reps to the show.
On the show notes.
The show notes. And initially, those new documents appear under the draft status. So even though they've been already discussed in the pull request, they will remain as a draft. They call them an open REP for a while, until it's stabilized, essentially, until more people in the community have tried them, provided feedback, and say, yeah, that's a solid standard, we should accept it.
Okay.
And then the final state is indeed to have an accepted REP that becomes a complete standalone ROS standard that people might choose to follow, to implement in their code, and etc. So currently, the ROS for HRI project has reached the first step. So it's now an official draft REP. So if you go on the list of all the ROS REPs, you will see the one called 5.5, which is the REP for the human-robot interaction, perception of humans for robots, essentially. And that document, so it's an RST, restructured text document, with like a couple of figures, examples, code. That document specify what I've called the API, or more like the interface that anyone who wants to write code compatible with the ROS for HRI standard can follow. And there is essentially three things. The first one is a set of messages. So those famous HRI messages that we've already mentioned. So if you use those messages, then your code will be able to interact with other nodes
compatible
ROS for HRI API. There is a set of naming conventions for topics, so that people know where to expect your new face detection, your new gesture recognition, your new emotion detection, etc. And lastly, there is a set of conventions for frames. So the human body has a lot of degrees of freedom. Part of the ROS for HRI API is to define a set, like a model, a kinematic model of the human, which is a simplified model of the human, but that matches quite well with what the state-of-the-art skeleton trackers are able to provide. And so we in the spec, we specify the name of those frames, the orientation of those frames, so that people working on the human kinematic can know what to expect, essentially. And there is a couple of additional frames about, like, for instance, the gaze direction or things like that are also specified.
Okay.
The ROS for HRI API is actually a set of messages, a set of naming conventions for topics, and a set of frame conventions.
Okay. Very clear. Yes, because when we mention about APIs, so maybe people is thinking about the web APIs for the typical web applications, or the API for a CPP library or something like that. In this case, it's more a ROS API that we are talking about.
Actually, you're mentioning libraries in C++ or Python. I quickly mentioned it earlier, but we also provide something called lib HRI and something called Pal HRI that are two libraries, one in C++ and one in Python, that makes it super easy to ask or to query the system for what are the humans around you, or where are they looking at, what are their age. If someone provides the age information, then you can access it from the library. It's a little bit like libTF. For those of you who have been using TF, there is this libTF that hides a lot of the complexity of managing all the transformation trees and things like that. So that's the same idea for lib HRI. It abstracts away the list of all the people, the faces, which face belongs to which body, all that, and offers a much higher level API in that case. C++ or Python API. Okay, clarified. Then let me ask you another question. So so you have explained already about how to use it, how to install it, but then what is the process for maintenance? So is this framework already made and is already done and finished, or is it going to be maintained and improve and increase in the next years? Let's say, who's in charge of doing that? So the standard itself, as we discussed before, is in draft state, which means that for the coming, 6 months, something like that, more or less, I will invite everyone in the community to provide feedback, to try to implement the standard, and we will probably make some changes. There's actually already 2 pretty important changes that have been suggested by the community that might actually change some aspects of the spec. So we will have that process for a couple of months until the spec is accepted. Once the standard is accepted, it might change a little bit, but it will be mostly it. It won't evolve, not massively. And if it has to evolve a lot, then we will create a version 2 that will be completely independent. But the whole point of a standard is to be mostly static and mostly fixed. So that is one thing. The other thing is, of course, the maintenance and the development of the libraries, of the nodes, and for that there is no real plan set in stone. The idea is, of course, that the community will start using it, so we will see more and more nodes that are compatible with ROS HRI available, open source on GitHub. If you go today on wiki.ros.org/HRI, the page is almost empty, so it's not a good example of a documentation, but it's already a place where people are invited to add the links to their nodes if they've created nodes that are compatible with ROS HRI. So the idea is really to grow like that and to share the maintenance of the ecosystem with the whole community. The maintenance of the key packages, like for instance the HRI messages, for instance the human description model, that is going to be, I assume, at least for the foreseeable future, for the next couple of years, that will be on my shoulders essentially. We are very invested here at Pal Robotics. We see it as a really critical piece of software, of ecosystem, so we are ready to dedicate engineering time to make sure that this part of the system will be well maintained for at least, like the next couple of years, because that's something we are currently heavily investing in. So it's something really important for us. So yes, it will be, all the basic infrastructure will be maintained for us. And if someone else in the community is interested to join in, I'll be very open to explore how we can make that work. And then, yes, the broader ecosystem of nodes then will be shared with the whole community.
Yeah, with the people that decide to apply, to create new nodes that follow this framework and so on. So then, based on that, that means that this framework is, once you finish the draft phase, then this framework is already finished. So there are no pieces missing unless somebody spots something that has been you didn't think about, and then now it happens. Oh, this is very important, and somebody spots it. But unless that is finished,
Yeah, the one thing that is important to mention though is that the current REP is really focused on perception and not so much on actions. It's all about how we model humans. It's not so much about defining standards to do something with humans. So if anything else, then we have no plans for that currently, but we might in the next year or so start working on the other side of the human-robot interaction problem, not the action. Action generation, behavior generation, and see what kind of standard would make sense there. So that may be the part that is not finished, not even started, but it's to a large extent it's independent.
Okay. So it can be appended afterwards.
Yeah.
Okay. Then let me see. So then. Can I say that then the most difficult part for other researchers that would be to adopt this standard? So what do you think about other researchers on human-robot interaction? Are they also using ROS for that? And then if not, then that would be difficult for them to start adopting this framework. What do you think?
Yes. The first thing I would like to say is there is a lot of interest, including from companies providing hardware to implement the ROS HRI standard. And I'm thinking very specifically at Microsoft. I've been in touch with Microsoft that developed Azure Kinect, as you know, and they plan to officially in their SDK support ROS HRI. So in that sense, if there is more and more companies, and of course all the academic colleagues that start to use it, it will become the de facto way of doing HRI. Another really important aspect is teaching, of course. It's really interesting because, at least in my experience, I've been teaching at the university for a couple of years. We end up teaching HRI on one side and ROS on the other side, which is a problem sometimes. So I think for the first time, for all the colleagues that are teaching or trying to teach human-robot interaction, we will be able to do that and integrate it better in the standard robotic curriculum that we might have. You don't need them as two separate things. Now the elephant in the room, so to say, is most of the research currently done in HRI is done with the SoftBank robots, Pepper, and Now. And those robots have their own APIs that are not ROS. They have their own Now key framework, where they offer a lot of human-robot interaction related capabilities. I think that today, with ROS HRI, we are at a stage where we can say that we now have a fully compliant, fully compatible ROS equivalent of that. And so there is no need to rely on this closed source proprietary anymore to do HRI. To be completely honest, I think there's still a couple of gaps that needs to be filled, but at least the structure is there, the infrastructure is there, and the capabilities are now there. So we can start teaching, start telling people, start writing tutorials saying, like, if you want to deal with humans on a robot, ROS HRI is the way to go. And yes, maybe that specific, expression is not, there's no node yet to recognize that specific facial expression. But you can already rely on the fact that when that node will be written, it will expose the results there, and this is all in the spec already. So I think it will really accelerate the uptake of human-robot interaction in robotics in general, because we have now solid foundations to expose to the ROS ecosystem all things related to humans. Awesome.
I also like it, especially this idea that you mentioned about on your classes at the university that now you can integrate everything. So before it was two separate things, human-robot interaction and then ROS, and now you have this possibility about teaching. That's awesome. It's going to be a good experience this year.
I want to mention so my former colleague from the University of West of England in Bristol, Manuel Giuliani, is currently, while we're talking, is currently preparing teaching material about that. HRI ROS using ROS for HRI that will be made available under a Creative Commons license, which means that any colleague will be able to take it, adapt it, reuse it. So we are really trying to make as much material as possible available to the academic community around that.
And maybe soon also at the construct.
I mean, he plans to use it this year to teach the HRI module this semester. So yes, very soon actually.
Okay, great. Then let's finish here. But before, I would like to know how. So you are teaching a workshop at ROS this year, right? About this. So, what can you give details for the people who maybe they are listening to this and they want to attend to this?
Yes, of course. So as you might know, ROSCon and IROS are next to each other. So I'll be officially introducing ROS for HRI at ROSCon. So I have like a plenary talk at ROSCon to present it to the whole community. And 2 days later, I will be organizing with two of my colleagues a very hands-on tutorial on ROS for HRI. Unfortunately, it will be in person only because my experience tells me that it's really hard to do hands-on tutorials remotely. However, we will try really hard to have all the material online as much as possible so that people can try to follow the tutorial at their own pace. And that will also hopefully bootstrap that kind of documentation / teaching materials / tutorials around ROS for HRI to make it easy for people in the future as well to learn about all that.
Okay, excellent. So that's all for today. Thank you very much, Severin.
Thank you very much.
Thank you. And for all the people there that you are listening to this program, so remember that you can learn a lot about ROS at the Construct Academy. So I will put a link also there in the show notes where you can learn about many subjects about ROS. Maybe not yet about human-robot interaction, but we'll see in the close future. And that is all for today. See you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.